welcome back. So I have been investigating further what's going on with this PNP transistor, and I found something interesting going on. As I have demonstrated with the circuit set up on the breadboard laid out as it is currently, everything will work. However, if I try to correct what's going on with this transistor, to have the collector be in the center, thankfully all I really need to do is move it over one place and then move a few things around. So my collector is the center pin and my emitter is still right here, so I don't even have to move the capacitor. And then my base is here. And turn this on, and the fan immediately starts running, and there's no way I can get it to stop. Alright? But I do notice that the transistor does stay cool, and what I'm finding is happening is along the base is carrying the VCC voltage, or what I'm calling the base is carrying the VCC voltage. And so, of course, that's going across the whole thing and causing the voltage on the op-amp to be high. Now, just to make sure I am thinking about the pins the proper way, I stick it in there backwards, and I'm getting the same thing. So, that is, yeah, something not going on properly there. But thankfully, to get it all back together the way I had it, because I did have nice little notes. Okay, so that's supposed to be the pin on the left. This is supposed to be on the right, and that's in the middle. So yeah, all I really actually have to do is just move one wire and move the transistor. And now, of course, I turn it on, and in order to get it to start up, I have to warm up the thermistor by sticking it in my mouth. And once I've warmed it up and take the thermistor out of my mouth, about 45 seconds later or so, the fan will kick off. Now, one thing that I have noticed is that these capacitors do take a little bit of time to charge up before the fan will turn on, before the capacitors are pushing enough current into the op-amp to cause it to rail high or change the state on the MOSFET over here. So I'm thinking that instead of having an adjustable time, I may just replace this potentiometer with a fixed resistor to the high voltage I believe it'll end up needing to be. I do need to kind of pull this yellow wire up off the ground voltage a little bit in order to have it function appropriately. If I just stick that straight into ground, it doesn't have anything, it doesn't have enough going into the op-amp to really make a difference. And so I'm thinking if I'm going to end up taking that potentiometer off, what I'll end up doing is seeing about redoing my capacitors. I'd still like to have this timing going on, and of course to have the timing going on, then I need to have some capacitors, and I need to have a way to charge and discharge them, and that's what the transistor is doing. But I could take out the right-hand potentiometer, replace it with a voltage dividing network of a couple of resistors, just to pull the voltage going into the inverting input on the second op-amp slightly up off of the ground. And then, of course, what's going on with the MOSFET would just stay the same. So, or I could just go ahead and leave it as is. If I play around with the temperature set point and the time set point, I can do this properly where I can say, hey, at a specific temperature, turn on the fan. When you drop below that temperature, stay on for a set period of time. Right now, due to the way that the capacitors charge, with the the potentiometer on the right, it's affecting um, the voltage to the inverting input on the second op amp. So the higher that is, the longer the delay between the temperature set point being reached and causing the first op amp to rail and open up the transistor. So if I really crank that, it'll end up causing there to be quite a bit of a delay between the time until the fan gets turned on. The way to resolve that without redoing the circuit would be to ensure that I adjust my temperature set point at the same time I adjust my time set point. That way, the temperature set point will be reached at a lower actual temperature, give these capacitors time to charge up. By the time the capacitors are charged up, well, then you'll actually be at the temperature that you think you're going to be, assuming the thing isn't just going way high with the temperature and just baking itself almost instantly. That should be all right. Or another option is just go with a straight on-off on the fan and see about averaging out the on and off time to adjust the fan speed. Because if I adjust the voltage going into this MOSFET, I should be able to adjust the speed on this fan, and that may be an appropriate solution right there. Temperature gets certain down to a certain point, the fan stops, but after a certain area it turns on slowly and then speeds up and goes faster and faster until you've railed out the op amp. Which is something I may wish to investigate. This is a 12-volt fan, however I do know it will run on 9 volts, and the amperage on this thing, it doesn't really take a whole lot. When this is turned on, the whole circuit, fan included, is about 1/10 of an amp. When the fan does kick on, it can have a peak current draw of 0.15 amps. But still, I mean, it's minuscule. And running the fan at 9, 10, 11 volts, something like that, shouldn't be a problem. But at a certain point, you are just kind of wasting electricity. Though, if you're trying to feed electricity through the fan, that doesn't actually cause the motor to run at any appreciable speed. So you have to put a lower limit on the voltage you're going to run the fan with. So anyway, until next time.